I would like to continue our discussion of the discrepancies in between standard programming languages, be it if you are writing in an imperative programming language or a more declarative one like Haskell. I don't think it matters because there is a real mindset change that need to be changed when you move to SQL. So I would like to focus on how you do this mindset change and some tips to help you writing SQLs more easily as a standard programmer. So I already said in the previous episode that as standard programmers, we are used to think by, let's take this complex problem, divide it into simpler ones, solve each one, assign the result into a variable, and then move on from there, and then we'll have the complex problem solved, because this is the basics of computers. You give it some input, you run some function, you get some output, you take this output, you run another function, you get another output, and you aggregate everything. But in SQL, it's a little bit different because you don't really see variables. You don't really see function calls. No, not the same function calls. You don't really write functions. So how do you split the logic? So let's take our example. We wanted to take the first flight that had a maximum amount of passengers on a daily basis. So if you were to solve this problem in a standard programming language, let's say Java, what you would do is that you would take all the flights, then count the number of passengers, and then divide them by each day. Maybe you have a map of key days. And then you take the maximum, the flight that had the maximum amount of passengers. You just split it to multiple stages, and you are able to do this because you can point to the variable that holds all the flights in this day with the loop, and then take the maximum, the max one. But in SQL, how do you do this? So I said that when you switch from an imperative language into SQL, then we don't have to lose all the benefits that we had in a programming language. Because usually what we do is we dump everything. We say, okay, now we're going to do joins. We're going to use window functions. We are going to use group, and we're going to have a mess of large SQLs. This does not need to be the case. So taking this example from a programming language into SQL and taking also all the tools that we have acquired in a programming language, such as splitting the logic into multiple subproblems, what we could do is create multiple tables. The first table would have the flights per day. And for each flight per day, we would also remember the number of passengers that it had. So the concept that is hiding here is that we are still preserving the concept of variable from programming languages. We are not losing it. This is the beauty of it. Because in programming languages, we had variables. So now when we move on to SQL, we don't need to lose it. We still have variables. We just call them temporal tables. So in this temporal table, and there are multiple constructs. You can use insert into, you can use the Postgres with, you can use create temp table, whatever you prefer. You take all the data, you group it by day, and you count the number of flights. So, and here is another trick. We need a variable to store the number of flights per day, right? How do we do this? The next trick is that we had variables and function calls in a programming language. We said that in SQL we use temporal tables for this, but not only temporal tables, we use also additional columns. So the beauty is that in SQL, when you need this new variable, when you need to compute this something new, then I want you, the first thing that you tell yourself is that I need a temp table or I need a new column. Okay, so not that we need a new column or a new table, but we said that we already have a table that would contain the number of passengers for each flight, for each day. But what was missing is to understand what is the flight that has the most number of passengers per day. So what would help us? What would help us is a new variable. This new variable would rank. It's like the row number of all the flights per day, and we would assign the row number 1 for the flight with most passengers for a specific day, let's say the 30th of October, and we assign the rank 1 or the row number 1 into the flight that had the most passengers, and then row number 2. And so if you look at this timetable, you have an aggregation by day. You have all the flights that happened each day. You have also all the passengers. The count of the passengers for each such flight, because we are grouping by day for each flight. And the beauty is that the way that we counted the way that we sorted the ranking, the index for each such flight, whether it was the flight with the most amount of days or not, is by applying a window function on a new column. So we created a new column and we use the window functions, row number, we partition by the day, because we want we want a new index 1 to begin in each day. So we partition by day, and then we sort by the number of passengers per flight. And then we have this temp table. This temp table is the new variable that we used in order to get the flights per day, and for each flight the number of passengers. But not only this, we use the window function, row number, to add a new column, and this new column is like a new variable. This new variable is what allows us to switch between programming languages and SQL. You need a new variable, maybe you need a new table. You need a new variable or a function call, maybe you need a new column. This is the mindset. Once you have this mindset, everything would be straightforward with SQL. Same thing. So we need a new column. Let's give a new row number, new index for each flight based on its ordering, whether on the ordering of how many passengers it had. And once we have this new table with this new column of this ranking, index 1, 2, 3, beginning each day, 1, 2, 3, 1, 2, 3 each day, then you apply over it. It's like a return value. You apply over it and you select only where the rank is 1, only where the row number is 1. And this is where the magic happens. So we have split the problem into multiple problems in SQL, and we did this in the same exact concept that we are using for programming languages. And we added a new table, temporal table. We then added a new column. For this new column, we partitioned by day, because we wanted the indexes to be different for each day. We want 1, 2, 3 for day 1, 1, 2, 3, 4 for day 2, 1, 2, 3, 4 for day 3. So we partition by day. However, how do we do this indexing? We say to the over partition by function that it should order by the number of passengers in a descending order, because we want the max flight with max passengers to be first. And then we apply another SQL on top of this result, and this SQL is going to be super simple. It would simply do a filter aware on row number 1. So we have taken the concepts from programming languages, applied them into SQL, and now our SQLs are much more easier. And guess what? They are going to be much more clean, because you didn't end up with a whole bunch of SQLs with some joins and with super huge amount of columns that you just have a mess with a big SQL. You have small SQLs because you are taking the concept from programming languages of functions, variables, and scoping. So I think this is super important. Please let me know if you have any comments in any channel when you can post reviews on the podcast. So just post them the comments, because I would really like to hear what you think. So thank you for listening, and we'll see you next time.